So here's today's question. What is science? What does science actually mean? We know it's a subject in school. We know it involves lots of math, so on. But what is it? So the word science comes from a Latin root meaning to know. So really, science is nothing more than knowledge. That's what it is. Science in our day is what we refer to as the method in which we acquire knowledge. There are different branches of science. The two main branches are life science and physical science. Life science being topics such as biology and anatomy, so on. And then physical sciences being the physical world around us, making sense out of physical objects. You have physics, you have chemistry, you have astronomy, weather, so on. So we have these two basic branches of science. Now the question is, how do we go about learning? What's the method in which we search for knowledge? The scientific method is a process we follow. It is a method of investigating so that we can understand through experimental evidence. Let's take a look and see how this works. The scientific method begins by making an observation of some aspect of nature. Once we make that observation, we want to understand what's happening, and so we propose an explanation. This proposed explanation is what we call a hypothesis. Once we have a hypothesis trying to explain what's going on with the observation, then we form a prediction and say, based on my hypothesis, I expect such and such a thing to happen. Once we make our prediction, then we have to experiment and to test in order to test our predictions. Once we've finished the experiment, then we observe again. Say, okay, did this work? Did it not work? And then as we make an observation from our experiment, then we have to take that observation and make a hypothesis. Okay, my prediction didn't work. Why didn't it work? The hypothesis should explain that. Then take your new hypothesis and make a prediction based on that and experiment on that prediction again. This goes over and over and over many times. An important thing to notice here is that there is no conclusion to this cycle. We always go from observation to hypothesis to a prediction to an experiment back to observation and goes in an endless circle. The reason for this is that there is no end to the knowledge that we can find. Now, the scientific method has gone on for years, perfecting our knowledge for centuries, always bringing us closer to truth. For example, the ancient Greeks observed that for some reason, objects always fall down. This is due to what they called gravity, a pull towards the surface of the earth. Isaac Newton further explored this and realized it's not just objects going down, it's actually an attraction between two objects. In this case, the object I dropped is attracted to the earth itself. And likewise, the earth is also attracted to this object. And he created his laws of motion through this concept. Johannes Kepler, a number of years later, furthered this by using Newton's laws of gravity to create the laws of planetary motion, which described the motion of all planets around the sun around the Milky Way, galaxy around galaxy, and so on. And it doesn't end there. Albert Einstein later on came and created a better understanding of what gravity is when he developed his famous general theory of relativity. Now, we use the scientific method in our everyday lives. For example, when you first learn how to cook, you don't know how to cook perfectly. Let's say that you want to cook a perfect chicken. You take it, you follow the directions, you put it in the oven, it comes out burned. There's your observation. Make a hypothesis. Oh, it was too hot. Oh, it was in there too long. So you have to make a prediction. I need less time. I need it a little bit cooler. Whatever your explanation is, your prediction. And then you experiment again. Let's do another chicken. Less time, a little cooler temperature. make an observation. This time it came out raw. So it didn't work this time either. So make another hypothesis, do another experiment until you come out with a perfect chicken. The scientific method is so critical in our pursuit of knowledge. If any part of the scientific method stops, then that stops the cycle. There is no way to advance to the next stage or to gain more knowledge. That is the end. There's one other bit of advice that I'd like to leave you with in regards to what science is. Here it is. Doubt nothing, but question everything. In the words of Michael Faraday, nothing is too wonderful to be true if it be consistent with the laws of nature. Here's an example of what I mean by doubt nothing, but question everything. After Albert Einstein came up with his famous E equals mc squared equation, many science fiction writers had wondrous ideas about generating power using this principle. Many scientists, including Einstein himself, doubted that this would ever be possible. But as scientists continued to press on learning, they learned that it actually is possible. And now we have facilities all around the globe that generate extremely large amounts of energy due to nuclear reactions using Einstein's wonderful discovery of E equals mc squared. So doubt nothing, but question everything. And that is how we do science. Welcome to the world of science.